Okay, we're going to look at how we calculate the product moment correlation coefficient. Now, what the product moment correlation coefficient is basically a numerical value which represents the strength of the correlation between two variables. So let's say you had a scatter graph x and y with variables x and y on it. Then if you could take all those variables and you could calculate a numerical value for the strength of the relationship between them. Now, the maximum it could be is 1. So if you have a PMCC, product moment correlation coefficient, of 1, then that indicates a perfect correlation. Okay, if you have a PMCC of -1, that indicates a perfect negative correlation. So it goes from -1 to 1 and 0. If you have 0, r is equal to 0, that's what we call it, sorry, we give it the name r, then it has no correlation at all. So there's no relationship between the two variables. Okay? So here you can see a scatter graph. You've got r is equal to -1. It's a perfect negative correlation. Here r is equal to -0.8. So not just as strong, but you can see it's a pretty good negative correlation. Here r is equal to 0. So absolutely no correlation at all. Here r is equal to positive 0.5. So it's a sort of moderate positive correlation, and here r is equal to 1, and it's a perfect positive correlation. Okay, you need to know how to calculate the product moment correlation coefficient for bivariate data. The formula is here, and this is given to you in your formula booklet. I'm just going to show you exactly what it looks like in your CCA formula booklet. So in the CCA formula booklet, the product moment correlation coefficient is, so you've got three ways of doing it. This is the one we're going to look at in our working out example here. Okay, so we need to be able to use this. Really, sometimes you're going to have to be able to plug into this formula. You'll be given values, so you'll see in the next example. More often than not, you'll just be given a set of x values and their corresponding y values, and you'll have to calculate r using the calculator. You will also, much like finding a standard deviation on a calculator, you'll need to find sigma x, sigma x squared, sigma y squared, and a new one, sigma xy. So we'll look now at how we can do that. Okay, so in this first example, it says there are 12 students in A-level mathematics class. Each student completes 2 tests, one in pure maths and the other in applied maths. The marks in the pure maths test P and the applied maths test A are calculated. The summary statistics are as shown. So they have given you these things. They've given you sigma P, sigma A, sigma P squared, sigma A squared, and sigma PA. It tells you to calculate the product moment correlation. So we'll look at how we do that first of all. So for the solution, that is the solution from your formula booklet. Instead of sigma xy, we have got sigma PA. Instead of sigma x, we've sigma A. Instead of sigma y, we've sigma P, and so on. But all the rest of it is the same. So we had 12 values. Sigma PA was 72266. Sigma A was 849. Sigma P was 985, and the n was 12. And the bottom line square root of the sigma A squared minus the sigma A squared minus sigma A, and that's all squared, and over 12, and then this was your sigma P squared minus your sigma P, then squared and divided by your 12. When you work it out, you get r is equal to 0.837 to 3 sig figs, which indicates then a strong positive correlation. Those students who did well in the pure test also did well in the applied test, as you would expect. Okay, in this example it says draw a scatter graph and regression line for the data below. Find the product moment correlation and comment on your answer. Okay, if you draw a scatter graph, I have done this very quickly and very roughly. I've drawn my scatter graph, and you can see there's very little correlation here. I wouldn't even be drawing a regression line for this. Right, we're going to go on and look at how we actually use this data to find our sigma x squared, y bar, x bar, sigma y squared, and xy, and most importantly, our product moment correlation coefficient. Okay, to do this, first thing you want to say is from your calculator. So you want to state that you're getting this from your calculator. And now over at the side, I'm going to give instructions on how we actually do this. So the first thing you do is you hit the menu button. And then this is on our Casio ClassWiz calculator. And then you want to go to y is equal to ax plus b. and that allows you then to input your x values and the corresponding y values. So input your x values and your y values. Okay, if your calculator is set up like mine, it will have a frequency column as well, which is all ones. Don't worry about that, it's fine, it's not going to make any difference to it. Then what you want to do is press your AC button. So again, don't worry, that data is stored. And then you want to press Option, and then you go to Variable Calculator, Variable Calc it says. Okay, that allows you then to get everything you need from your calculator. So from your calculator, you'll need to get X bar, and if you get X bar, you get 46.4. You get sigma X, which is 464. You get sigma X squared, which is 26084. You get Y bar, which is 572. You get sigma Y, which is 37462, and then you can get your sigma XY. I've missed one out, have I? Oh, yep, sorry, that was not right. My sigma Y was equal to sigma Y is equal to 572. My Y bar is actually 57.2, and my sigma, we need to do our sigma X, sigma Y squared is going to be 37462. Okay, the new one for saying, which we wouldn't have seen before, is sigma xy. It's just down in that list of variable things that they're giving you. So that's going to be 27176. Okay, so you've got everything. You haven't got the most important thing. You haven't got the R. So to get R, you need to hit Option again, and then you want to go to Regression. And once you go to Regression, then you calculate R. And if you do that, you get R is equal to 0.137, and that's the 3 sig figs. Now remember what that means. If R had been equal to 0, that would have been no correlation. So this shows little correlation. Okay, it shows little correlation. So let's just go back up to our thing and see if that makes sense. And if you look back at your scatter graph, really, if you were to cast, this is why you shouldn't really do a regression line for this one. If you were to cast a circle around this, a shape around this, it's sort of circular shape. There's very little correlation going on here at all. So that's why your R is so small. Okay, you're now ready to do it's exercise 2B. And questions 2 to 6. The extra one there you could do would be question 10. There's other questions there, but they're the ones we really need to focus on. And also then there's an exercise 1B, the odds. Okay.